Head Department of Geology, Andhra University, Visakhapatnam. So in this regard, may I request Dr. Sudarshan, Dr. Srinivasa Gaud Garu, Associate Professor, Department of Geology, to introduce Professor K. Satyanarayan Reddy Garu to the audience.
Morning all. It's my pleasure to introduce Professor K. Satyanarayan Reddy sir, Head of the Department of Geology, Andhra University, Visakhapatnam. Professor started his career as geologist in the Atomic Minerals Division from 1978 to 88. Then he shifted to the Andhra University as assistant professor, then promoted as associate professor. Good morning all. It's glad to introduce Professor Satyanarayan Reddy sir, Head of the Department of Geology, Andhra University, Visakhapatnam, to introduce to the workshop. Professor started his career as geologist in the Atomic Minerals Division from 1987 to 1988. Then he moved to the Andhra University as assistant professor, then promoted as associate professor, then as professor. Presently, he is heading the department and he is the director of Delta Studies Institute. And professor specialization is marine geology, sedimentology, and placer minerals. And he has published more than 40 papers in the national and international reputed journals. And he has completed more than 11 PhDs under his guidance. And professor has conducted the most prestigious training courses, particularly in the ONGC and oil sector, where he is very close to the KG Basin. He has completed more than 20 training courses. And he has organized 6 seminars to his credentials. And regarding the membership of the professional associations, professor is a life member in the Indian Science Journalists Association, life member in the South Asian Association of Academic Geologists, life member in the Indian Academy of Geosciences, life member in the Indian Association of Sedimentologists, life member in the Instrument Society of India. And besides, he is in a very busy and responsible administrative career he has headed. He is the department, besides his Department of Geology, he is the director Delta Studies Institute. He has the chairman board of studies for the Central Tribal University of AP, Vijayanagaram, and many institutes and departments. He is the board of studies chairman member for so many colleges and universities like Adhika Vinana University, like Andhra University Department of Geography. And he is the member in the professional related committees and state level and national level also, like coordinator for a first expert subcommittee meet on application of geosciences and other relevant areas for weaker section of the society, university nominee on the governing body of Sri Venkata Saidagiri College. Like that, there are so many membership for his credentials. It's my pleasure to invite Professor Satyanarayan Reddy sir to the national workshop. It's over to Professor Sunita Garu.
Thank you, Srinivas Gaud sir, for introducing Professor Satyanarayan Reddy Garu. Now, may I request Satyanarayan Reddy sir to share your PPT, sir.
Okay, madam. So thank you for your kind introduction and all. Thank you, organizing committee, to invite me to deliver the talk on this recent trends in mineral exploration. Next, now I am sharing the presentation. Yes.
So your time will be around 1 hour to 1.5 hours, sir. After then, we'll have some interaction session. Is that okay, sir?
Okay. Okay.
Thank you. Please go ahead. you, sir.
Yes, are you able to see the screen, ma'am? Hello.
Yes, sir. Yes, sir.
Okay.
PPT is not shared, itself.
Not shared?
Yeah, yeah.
One
Not
minute.
shared.
1 minute.
Okay. Okay.
Okay. Share out. Okay. 1 minute. So share out. Not yet. What share this? ఇది. Now it's okay, madam?
Yes, sir. Yes, sir.
Okay, okay, right. 1 minute.
Yeah, please go ahead.
Good morning to all of you. Yes. Are you able to hear me? Hello. Hello. Hello.
You are audible, sir.
Are you able to hear me?
Yes, sir.
Okay. Measurement is come. Where is it? Okay. Today my topic is, are you able to see the screen?
Yes, sir. Yes, sir.
Okay, okay, right. Today my topic is recent developments in mineral exploration with a special reference to organic fuels, especially petroleum and natural gas. Yes, and the people who are very new for the mineral exploration, just I will give some brief introduction about mineral exploration. Then I will go for the topic. Yes, mineral exploration is a systematic scientific study to know the location of mineral deposit, either any deposit, either metallic, non-metallic, or fuels, whatever may be. Our main target in mineral exploration is to find out the location of the mineral deposit and to estimate the quantity of the mineral deposit, size, shape, and tonnages. And the other thing is to assess the quality of the mineral deposit and potential. Can we able to mine it, or are we able to extract it with existing and available technology? And last one is the academic viability. That is, a profitably or not compared to study to markets and all. Therefore, altogether, the entire study is a part and parcel of the mineral exploration. Now, yes, everybody knows, yes, this Earth is so big planet, the radius of more than 6,000. As far as our exploration is concerned, we are confined to the topmost layer of the lithosphere, and most of the mineral deposit exploration and all is the especially coal, natural gas, etc. Coal and coal but methane, etc., which are less than 1 kilometer, and oil and natural gas, it will go up to 5 or 6 kilometers. And most of the metallic and non-metallic, it is very depth, that is almost less than kilometer, except for very few mineral deposit like a Kolar gold field in India, which will go beyond 2.5 kilometers. Therefore, Earth as a whole, our activities are very topmost layer of the Earth. Therefore, mining activities and all, most of the people said it is going to impact human and so other things. We'll discuss those things later. But the time being, our activities are the uppermost layer of the Earth, that is a part of the lithosphere. And the ore deposits are any mineral deposit. For example, in the metallic or other non-metallic deposit, ore is a rock in which valuable minerals, typically metal, occurs at a concentration sufficiently high relative to average rocks to make it economically profitable mine. In terms of oil exploration and all also, the oil reservoir, what we are called as a reservoir rock, where the oil is stored, and whether the size of the reservoir and yield of the reservoir, etc., we will take into consideration. It is considered as a good reservoir. Now, the mineral, other minerals point of view, yes, there are minerals are various forms, bedded veins, irregular pipes, massive, disseminated. And exploration point of view, we will generally take into different methods of exploration, either geological methods of exploration, geochemical methods of exploration, and geobotanical methods of exploration. Now, the geological methods of exploration will take the geological knowledge, especially the physiographic guides like geomorphic and structural guides, types of structures and fracture patterns, and stratigraphic guides, the stratigraphy periods in terms of age and all, and lithological guides, the rock types, and mineralogical guides, associated minerals and mineral alteration products. We will take the especially the knowledge on the physiography of the earth and the structures of the earth, the stratigraphy and the rock types and mineralogical, etc., etc. We will take the help of these parameters and we will try to find out the mineral deposits, and all the exploration activity will take based on these background. Another thing is geophysical methods, and most of the geological methods we will see from the surface, and we will go for some of the sections like the river valleys and other issues. But the geophysical methods have some advantage, that is, we can understand the subsurface geology by using different geophysical, that is the geophysical properties of the materials. Like the gravity method, we'll use the density of the materials, magnetic methods, magnetic susceptibility, electromagnetic methods, electrical methods, which is the resistivity or conductivity, etc. And seismic methods, acoustic impedance, that is the velocity of the sound, and radiometric methods, MRA, emissions, etc. Therefore, in all these methods, our main aim is to understand the materials, and wherever there is try to find out the anomaly, and we try to understand the reasons for anomalies, and based on those things, we try to locate the mineral deposit. Now, generally geophysical surveys, especially there are so many things, but the mainly the petroleum exploration and all, we will use the seismic method, and especially that is how the sound waves will travel. That is the travel time of reflected and refracted seismic waves in various units of the earth, and we will take into that consideration and we try to find out the location of the coal, oil, and gas, etc. Therefore, our target is to find out the location of the mineral deposit. The best method exploration is the seismic methods. To understand some of the basement characters and all, we can go for the other methods and the gravity and magnetic, etc. Yes, in the we can use the geophysical models where there are data acquisition, the expected responses and logistical cost constraints, that is survey designs. We will make any exploration. We'll first plan for the surveys, etc. Then we can use some of the instruments to collect the data. Next is there are some corrections for the data also. That is the part and parcel of the processing of the data. Then data displays, and it is in the form of the products. Then by using the different display products, and finally we try to interpret the data and we try to achieve our targets, that is outcomes. Therefore, in this is the general procedure layout for any exploration. And other is the geochemical methods of chemical, atmogeochemical, hydrogeochemical, and biogeochemical. The pedogeochemical method of exploration, we will use these soils as samples, and based on the chemical, geochemical anomalies, we try to find out some mineral deposits. Lithogeochemical, the rock, will take the rock samples and will chemical analysis. Then sometimes we will collect the gas samples, and in hydrogeochemical we will collect the water samples, either surface and subsurface water samples, and biogeochemical will take the organic matter either from plants or animals, etc., etc. In all these methods, we try to understand geochemical distribution and concentration and analyze the elements or the ions. Based on those things, we try to find out the mineral deposits. Then these are the broad exploration methods. The botanical method of exploration. And in any exploration, there are the stages of mineral exploration based on the degree of assurance, and that is the accuracy, and by what technology you are using and all. And there are based on the number of samples and degree of assurance. We classified into different things. That is a first G1, G4, that is a reconnaissance exploration. That is a, then is a prospecting, that is G3 level. Then general exploration, that is G2 level, and general exploration in detail, that is the final exploration, that is a G1 exploration. Any exploration program can be classified by success. It is designed to achieve combined specific objectives within the time schedule and allocated fund. And the outputs of each stage provides inputs the next successive stage. Therefore, the G4 exploration output will be helpful to go for the G3, helpful to G2, like that. There is a each stage. What are the outputs you are achieving? Those outputs will be helpful for the success stage of the exploration. Then in a general mineral exploration, we will go survey, acquisition of the geophysical data, and synthesis of all available data and concepts, obtaining permission for the state or central government organization who are the empowered to give those things, and we will go for the license from the organization, and then that is a prospecting license. Then we will go for the mine lease, etc. Then the G3 and all, that is the next stage, and G3 is the next stage, then G4, and G1. It is a detailed exploration. The detailed exploration, the mapping is will you prepare a large scale maps like 1 to 5,000. If necessary, we'll go for the drilling and borehole geophysics, that is a mud logging, etc., and oil drill exploration, and other mineral deposits. We'll go for the trial mining, surface entry, mine development, one or more levels in case of underground mining. Therefore, the metallic and non-metallic mineral exploration will go for the trial pits and drilling, diamond drilling, and all. Will collect the core samples, which will use to understand the mineral dimensions and tonnage calculations, etc., in addition to indirect methods. But in oil well drilling, and mostly we will depend on the geophysical exploration methods. And based on that, we will try to find out the reservoir positions. Then we'll go for the drilling, explorator drilling. And next stage is the mud logging stage. That is based on the mud logging characters and all, we try to understand the reservoir characters. Then that is the general background for the mineral exploration. But the other issue here is, what are the recent trends or the developments in the mineral exploration? There are the traditional methods of mineral exploration. We start from the geological mapping, and by using the topo sheet, then we'll go for the geological mapping. And we try to understand the lithology, structures, each and everything, we try to map it, and we will prepare sections and all, and we will use the traditional geophysical methods. Now, there are a recent developments in the geological mappings. In the geological mapping, now we are using the remote sensing, which is a very good tool to do geological mapping and GIS techniques, and DGP is a differential global position system and kinematic global position system surveys, which is faster and which is more accurate, and the precision. Those things we are able to use in the mapping part. Then exploration methods also, there are recent and exploratory drilling part of view. The drilling technology also, there are a lot of advancements in the drilling technology and analysis point of view also. Previously, we'll collect the samples in the field, we'll bring to all the equipment which is available or installed in the laboratory, we'll use those equipment, we try to analyze the samples. But now there are mobile laboratories and portable instruments which are available, and we can use those things. We will do very fast the analysis part and all. Okay, in the field itself, simultaneously we are doing so many things, not only drilling, simultaneously we are doing some analysis in the mobile laboratories, etc. Then the data maps and interpretation maps also. Now there are different cartographic techniques. By using those techniques, we can easily prepare the maps and interpretation also. Previously, we will prepare a geological map, geophysical map, and various maps. We try to overlap one another. It will take a lot of time. But now the interpretation is a fully automatization interpretation. There is a computer-based programs are available, which are very advanced techniques of interpretation is available. Model development. Any or mineral deposit is a three-dimensional body. Suppose in the petroleum and natural gas and all, the reservoir is a three-dimensional body which hold our interested petroleum or natural gas. Therefore, many software programs have emerged during the past decade to drilling and mining databases and images, data interpretation platforms, facilitate information management, and the 3D reconstruction of the mineral deposits, reveal its shape, size, making it is easier to devise an exploration and do mining strategies. Drill hole must be positioned with great accuracy, since the drilling trajectory may be deviate significantly from its intended path, it is important to obtain a special coordinate to understand the drill hole and its exact drilling path. Now we have a very good technology. The downhole survey probe measuring the depth determines the orientation of drill core at the bedrock from which it was extracted as absolute orientation in space, in which case gyroscope is a part of the device. The information can be added to the integration platform for the process of information management on developing three-dimensional models. Therefore, the locations wise, we are doing our work in exact and precise locations. Not only that, the drilling programs and all, we can able to understand the drilling deviations, and we time to time will make it correction for the drilling, and we can go exactly which direction you want to make a drill hole. Now the portable analyzers are available. The tool identified the chemical elemental analysis and all, comparing the rock surface using X-rays, and it provides on the spot results, which helps to avoid unnecessary sampling and analytical testing at a laboratory. This time saving device thereby reduce the environmental impact of the exploration. Then remote sensing, its applications in the mineral exploration. Yes, it is a very specialized tool to get here. Now the advanced remote sensing is a hyperspectral analysis. Or range, the hyperspectral images used for the mineralogical mapping in mineral exploration, capable of characterizing every mineral in the borehole. The device, also known as a core mapper, takes an image for every 2 nanometers of a visible near-infrared spectral range, current wavelength from the 400 to 1000 nanometers. The 300 monochromatic images are then compiled. The result is a very detailed drill core mapping. Therefore, such accurately we are able to understand by using the hyperspectral techniques. Now, the software's point of view also, there are a number of softwares like RTGS, ERDAS, Anisys, and Minex, and photogrammetry, AutoCAD, GStats. There are so many softwares which are helpful to process the data. Now, remote sensing also, there are a number of the satellites which will provide a lot of information, Landsat to the IRS images, series. Like that, there are so many satellite data with the different resolutions which are available in the free of cost also. And by using and downloading the data, we can do so many things, especially in the exploration activities. The key information application include, we try to understand the topography, surface erosion, land distribution, rock types, and surface signatures, contribute to capture the existence of a near surface deep-seated deposit as possible exploration targets. Then vegetation, prolific scanty, and anomalous colors, and toxic effects, drainage patterns, guide planning, geochemical sampling, etc. Therefore, for you want to plan for, and by using these remote sensing techniques and all, we can go for a proper planning of the sampling to understand the surface drainage pattern, surface soil characters and all. Approach is most significant for mineral deposits occurring at remote inaccessible areas. That is very important. Otherwise, it will take a lot of time to reach inaccessible areas. But now it is very good remote sensing. We can do mapping and other activities by using the remote sensing. The main types of deposits and the surface indicators are the remote sensing data. There are a number of the things. Botanical indicators are there by remote sensing and all. We can able to identify species, index plants, etc. That is indicator plants. We can able to identify very easily the mineral deposits. Then some of the deposits which are magmatic segregation and differentiation, etc., like a chromite, magnetite, helmet. So those deposits we can easily identify based on the surface expressions, and there are some minerals, that is a minerals, associated minerals, and those mineral alteration products will give clue for so many mineral deposits. Then other mineral deposits also. These are the actually the metallic and non-metallic mineral deposits. And our petroleum resources wise, we will use the other techniques, especially the geophysical techniques to understand it. But earlier identification of the petroleum resources by the petroleum seepages also. Okay. Early discovery of petroleum in India is based on the seepages. Therefore, those things also we can identify through our remote sensing or in a detailed geological mappings. Right, in the remote sensing, we can use the hyperspectral data, multispectral data, panchromatic data, and aerial photographs. Now we can, there are so many advancements in remote sensing. Those things we can use to map the area and accurately. Right. And then these are some of the details here sensing. Yes, now we are able to prepare so many maps, and we can overlay these maps, and we can try to interpret exact locations and anomalize. Very good tool to make the maps very accurately, and interpretation also so easy by using the remote sensing techniques. Then here the real ground, and we can have a common system, and we can go for the geochemical maps, geology maps, and elevation maps, hydrogeology maps. We can make a overlay in it. We can easy to interpret. Then the chemical analysis also, the techniques which are available is the we will take the sample, and we will try to identify the minerals megascopically by using simple hand lens and all. Then stereo binocular microscopes are available. Now we have XRDs and electron and ion probe mineral microanalyzers, and scanning electron analysis, autoradiography, and cathode luminescence techniques. And here also the data which are collected by these methods, we can use. Our interpretation is very easy. Then the geochemical exploration also, actually we will use the different, our target here is to identify the anomalies, and whether you can use the pedogeochemical or biogeochemical or the lithogeochemical or hydrogeochemical, whatever whether it is for sample planning, that is survey planning, and next is exact location where you are collecting samples and all. The disk of geochemical anomaly, or the area where the chemical pattern indicates the presence of the ore in the vicinity. And the gas geochemistry, this is other field where we can collect the gas as a sample and detect several different gases and sufficient amount like mercury, oxygen, carbon dioxide, and radon. The nature and concentration of these gases provide clues about which minerals occur at depth. As a result, whether an ore body may be present or not. The method is currently subject to methodological testing, has already been used in the field of the geothermics. Then geochemistry can be used to detect metals in surface materials, consequently predict the presence of underlying ore bodies. Once difficult to possible to mineralize zones masked by the barren cover such as the sand and other things. We can able to collect the samples and we can do wonders with the geochemical techniques. And instrument wise, in the geochemical instruments wise, there are a lot of advancements. There is the X-ray fluorescence techniques, spectrophotometry, and laser ablation, and ICBMS, and solution and ICP, AES, carbon hydrogen moisture analyzers, laser microscope, electron probe microanalyzer, and even if you take just one grain, we can understand the chemistry of the grain and we can do mapping of the grain chemistry by using the electron probe microanalyzer. And anyhow, the X-ray powder diffraction, that is X-ray technique, study technique, and atomic absorption spectroscopy, and scanning electron microscope, and flame photometry. Especially in the petroleum exploration and all, we'll study some of the microfossils, and this scanning electron microscope and the morphology of the fossils, microfossils, and their morphological characters, etc., etc. That is a very good instrument, the scanning electron microscope. Now there is a multi-parameter probes. It is important to quickly determine the geophysical properties of the well, their magnetic characters, and ability to transit electrical currents and all. The multi-parameter probe, such as the MPPP, it is a model can instantly measure the properties of the sulfide minerals contained in samples at the surface. The probe measures magnetic susceptibility as well as the relative and absolute conductivity values. Therefore, here in the petrol exploration and all, we will make a drill hole. The next important thing is mud logging. That is, we will send the different electrodes, and that is, we will try to measure so many parameters, more than 40 parameters we can measure, and those at a different depths. Suppose it is a 3-kilometer drill hole from the surface to the bottom of the hole, and each and every inch the parameters will be measured and it will load it. Then it will go for the litho logs and various logs, they will be created. Therefore, the multi-parameter probes which can be loaded through this drill hole will cut a lot of data. That is a very good advancement. And LAMROC is analysis laboratory, determines the mineralogical and chemical characters, rocks and minerals, and it is actually now the labs also. There are sophisticated equipment you can keep in the mobile lab, and that lab is available and at the drill hole site immediately. Whatever the sample we are getting from the drill holes, we can able to analyze it. Yes, these are some of the equipments, and hydraulic rock splitters, swing jaw crushers, vibratory rig wheels, and sometimes the geophysical circuits. Now the new inventions, the magnetics, susceptibility and dominance stock standards, then gravity, density, mush, airborne, and radiometrics, chemical concentration with their resistivity, conductivity, then through IP electrochemistry and electromagnetic conductivity, susceptibility, and dielectric permittivity, and so paramagnetism, and seismics, density, rigidity, used in hard rocks, modeling, and inversion. There are the different techniques which are available. There are significant improvements in detection of modeling, remnants, and despite sensor measurements, and improve the resolutions also. The magnetics still primarily used in a spatial imaging tool. Gravity also, ground gravity measures nuclear instruments, easier to use, more reliable. More borehole gravity instrumentation available, and holds expensive reliability issues and acceptance routine tools, airborne gravity and gravity and gradiometry, mature methodologies, and incrementally improved systems continue to be spent on getting better airborne systems. Therefore, in the other these, every airborne sensor uses measurements, that is, it measures hundreds of spectral bands, as ordinary satellites measures only time. And by combining these spectral bands, it is possible to identify not only different vegetation covers and all, and this is used to directly produce rock maps in areas lacking ground cover. The first such satellite was launched in 1997, Levis hyperspectral imaging. Therefore, there are so many advancements in this field. Airborne gravimetry technique is to detect minute variations. The Earth's gravitational field, mineralized bodies are denser than the surrounding rocks, slight drop the gravitational field that can be detected highly sensitive instruments called gravimetric approaches relies on having highly accurate provides good information down to the nearest centimeter in order. Advances in geopositioning system, signal detection, allow gravimetric measurement precisely located in space. Airborne gravimetry significantly lowers acquisition costs and should revolutions rise minimum exploration in the years to come. Then magnetism also, there is a airborne electromagnetic surveys. The airborne electromagnetic surveys have used century in mineral exploration. Nevertheless, the technological advances in the fields of geophysics and electron data processing have led to the development of much sensitive instruments capable of detecting even deeper exploration targets down to 250 meters below the surface of the some areas. And interferentism development the exploration of base metals, this is, and to detect some metallic sulfide mineral deposits. Radar lasers can be used to map the topography of the region accurately, mounted on an airplane. Radar, that is a ALTM survey, can be determined the altimetric position, and two GPS devices to calculate correct the location of instrument, and on the one on the aircraft and the on the fixed location on the ground. This type of mapping is both faster and more accurate than conventions. It is a lower pack seismics. Therefore, seismics are more important in the petroleum exploration. The principle behind the seismic geophysical methods consists of creating shock at the earth surface using hammer or explosion, which generates signal that receives the detection system. That is the main, where induced the sound waves, and again we have geophones and all will detect the sound waves, where the sound waves, the travel time, travel distance, you can measure it. Analyzing the responses determine the nature of the rock subsurface. Explosions can be harmful to the environmentally, particularly systems. Improvements in signal capturing, signal processing mean that seismic signals can now be much weaker. These more sensitive instruments in less damage to the environment. Therefore, previously they will conduct a sound wave. They will create a sound waves by big explosion. Now, even the small explosion can we can able to detect the sound waves by because of advanced instruments. The term low impact seismic describes intrusive shock emission methods and lighter geophones. Right. The advances in geophysical methods, the radiometric methods, airborne multi-channel gamma ray spectrometers equipped with 30 to 50 and scintillation detectors, etc. existing system. Now the advancement is higher density calculations such as cesium 4.51 cubic meters. Those are the advancements which are of the lower and higher energies. And electrical and electromagnetic methods, that is the DC multi-electrode method is the older one. Now the spectral induced radiomagnetic telluric methods and surface nuclear magnetic responses methods, reflectometry. These are some of the advancements in the geophysical methods. And in the gravity method, there is a now we have a electronic gravimeters 0.00 m, that is milligauss, and CG3 digital gravimeters, the gravity station surveying, airborne gravity radiometry system, full tensor radiometry. They are the very advanced equipment in the gravity methods, axis magnetic radiometry technology, proton precision magnetometers, flux gate magnetometers. Then earlier days we are using the 1D, 2D, 3D seismics. Now we are using the 4D seismics. Now in the seismics, especially in the earlier days, the geophones are placed at various depths down borehole to record responses to shots fired at its surface. Acoustic loss can be lost. And 2D, that is geophones are placed along quarter line of the Earth's surface, and shot is fired from a location among those geophones. Thus, in that line, geophones and shot points are then moved along the line many times. That is through 2D. Then 3D, geophones are placed in a two-dimensional array on that surface. Sequential shots are fired from surface that moves through the area of this array, shooting at the exact same locations of individual geophones. Then 4 dimension, that is a 4D, and 2D and 3D surveys are repeated through the time over a known accumulation, and it is exploited. In good cases, geophones locations are identical through time. In ideal cases, geophones are fixed and remain the place of the lifetime of the survey. Therefore, in the 4D surveys, it is a dynamic surveying system who can collect the area-wise, depth-wise, time-wise, time series-wise. We can able to collect the seismic data. That is the very advanced technique. That is 4D seismics. Well-established in soft rocks also, significant improvements in hard rock and horizontal laid environments, high resolutions but high cost. 3D arrays, big data will get better, and brownfield targets only in resistivity also, high powered transmitters and distributors are there, and massive OH and S issues. No breakthroughs in the offering, then continuing misguided pushes to get manual discrimination from IP data because it is a desirable. Now, the inversion algorithms, geophysics is traditionally used to predict position of the mineralized body by seeking out the anomalies of the magnetic and gravitational fields and electrical conductivity. Now, the new inversion algorithm used to different way. First, establishing the geophysical properties of rocks, then measuring their geophysical signature in the field. It is possible to generate three-dimensional models of their potential mineralization and surrounding geophysical and geological environment. Therefore, inversion algorithms have led to many discoveries of the copper gold deposits. Therefore, our main objective in a mineral exploration is we try to find out the deposit, exact depth, shapes, size, orientation, and the chemical. Therefore, always we try to discriminate our ore bodies are reservoir rocks and reservoirs from the surrounding rocks by their geophysical characters. the seismic methods. These are the 4D seismics. Now, ultimately, we try to develop a model for the oil using these different techniques, loss techniques, exact the reservoir position and size of the reservoirs and shape of the reservoirs. The next issue is there is a oil, there is a estimation of the uh, in place oils and all, and 1 minute. Now, actually, one target is to identify the deposit where it is. Next target is to estimate the tonnage. And the metallic and non-metallic deposits, how many tons of the material is available, and what is the grade of the what is that is a part of the parcel of the estimation of the reserves, that is with the different grades. But in the oil exploration and gas exploration, there are different methods of estimation. That is the volumetric methods, material and virgin oil in place. That is virgin gas in place. Recoverable reserves usually in the life of the field, and it depends upon the quality description. And we are able to understand very clearly what is the tonnage, that is how many cubic meters or how many barrels of the oil is available in the reservoir. Then the other method, this is a material balancing method. In addition to the virgin oil in place and virgin gas in place, uh, there is a recoverable resource that is most important. The reserves which are available within that there is a how many million cubic of oil or gas we can able to extract from and the quantity of the reservoir description. Therefore, to want exact resource estimation, we have to understand in detail about the reservoir characters. Okay, the porosity and permeability characters and reservoir conditions and its pressure, temperature, each and character of the reservoir, we should understand. If our understanding of the reservoir characters are increased, yes, we can able to go for the accurate estimations in the oils and gas. And especially the recoverable reserves use of after a moderate amount of production data is available. Sometimes this is a dynamic system. Therefore, once you start production from any oil well, yes, time to time we collect the data, that is production data. By using that production data, and next the predictions will be takes place. Depend on the amount of the production history available, resource estimate tend to be realistic. And analogy is recoverable reserves use developments highly depend on the similarity of the reservoir characters. Reserves estimates are often very general. But the thing is, reservoir in the petroleum reservoirs or different types of reservoirs are there. Each reservoir has its own characters, and we try to understand those characters by means of the different geophysical and other techniques, and better understanding will give you better accuracy. Now there is different softwares are available. That is a petrol software, oil and gas, data mine softwares, exploration and mining, and economic viability studies also. There are different models in the economic viability studies for each mineral deposits, for pleasant mineral deposits, for metallic, non-metallic, coal, oil. Each mineral deposits, there are better softwares are available to study the economic viability. Then, yes, the positive aspects and negative aspects of these technologies is spending money on importing technologies. Now, all the technologies are not indigenous technologies. We are a lot of technology from the other countries. Therefore, we are spending a lot of money to import the technology, skilled manpower, machine mining, and also for processing of the ores and the land development of the trees, lead to cutting the trees, etc. That is environmental issues. And there is a air pollution. There are some pollution issues and environmental impact issues. But nowadays we are uh, sustainable development, and all our mining activities are sustainable activities. We try to minimize the environmental impact in the oil and gas industry as well as in the other mining industries. The technology wise, it is very costly affair and all. Then other important technology here and the offshore drilling. Then the drilling is very important issue. Then the land drilling is different and offshore drilling is different. For offshore drilling, we have to construct the offshore platforms, the floating platforms from the rigs, and here there are the vertical drilling and sometimes incline drillings and all. Now there is a technology is available, and there are different type of the drilling vessels and drilling offshore platforms, etc. Now there are vessels also there, and so I will show some of the right. There is a now also we'll make a drill holes in the offshore, and that is a direction drilling. And previously we should have some drill ships, and sometimes there is a platforms we have to construct it. Instead of this, now there is a technology to make a drill hole, offshore drill hole from the land. That is direction drilling and all. That is very good technology. And not only that one, monitoring of the drill holes. Therefore, we need not be stay at the drilling site. Yes, some people can be sitting in the offices. They will monitor online monitoring of how the drilling is going on and what are the parameters. Well, they try to analyze online. Therefore, that is advanced technologies. And other thing is in the oil industry, the production, the whatever the gas and oil which is available in the reservoir, we try to extract it. But now there is a new technologies in the oil and natural gas sectors have enabled the exploitation of the production growth in the United States and the shale revolution. That is what we are called as there is a hydraulic fracturing. And here we will inject the water and we will try to create the artificial, that is a induced porosity, that is secondary porosity will create in the reservoir rocks, so that if you increase the porosity, that is interconnective porosity will also increase, which will enhance the production rates. And that is one technique. Other thing is in combination of the hydraulic fracturing, there is the other technique which is called horizontal drilling. The drilling in the borehole, from the borehole, we can put a horizontal drill holes in the exact horizon where we are getting the oil or gas. Therefore, and our purpose is to enhance the production. Therefore, for that one, we can make a horizontal oil bearing horizons or gas bearing horizons from the drill hole. That is a very good technology. Now, the combination of hydraulic fracturing and horizontal drilling allows producers to access reserves of oil and gas from the low permeability geological formation that were previously too expensive to extract it. These are some of the techniques. One is hydraulic fracturing, horizontal drilling. Now there are tar sands. From tar sands also they are able to extract the oil and gas. Then deep water drilling. This is a very good technology. Previously only shallow water drilling, but deep water drilling is costly and high high technological instruments are required. Now we are able to go for the deep water drilling, and there is seismic maps also. There are good advancements, and there are some environmental implications. Okay, thank you. This is very briefly about the some of the technologies which is available in the mineral exploration. Hello. Hello.
Thank you so much, sir. Am I audible to you, sir?
Yes, yes, yes.
Yes. Thank you so much, sir, for the
Okay,
illustrative
thank you.
aspects of mineral exploration, geological methods, remote sensing, and so on, sir. I have a couple of questions here. Is the
Hello. One minute. One is your voice is not audible. Yes, there is some disturbance is coming. Please.
okay.
Hello. Okay, I will share the presentation. Okay, to organizers. Okay, you can share it with the participants and all. Okay.
Sir, about this mineral software, is it
One minute. Yes. What's your question?
mineral software, sir? Is it based paid software?
Mineral?
Mineral search software. Mineral search software.
Okay, sorry, I am unable to voice clearly. There is noise is coming. Please, please mute all the mics except the speaker.
Hello. Yeah, sir, I was asking about mineral search software. Sir.
Yeah, minerals.
Search software was there in PPT. That means can we download software?
No. I am unable to hear your voice. 2 or 3 voices are mixing. You know.
Okay, sir. Am I audible now?
Yes. Now you are audible.
How about this Lamrock multi-parameter method, sir, for estimating all the geochemical parameters? Is it a mobile kit or something? What it is, sir?
Yeah, not kitty actually.
Okay.
There are in the, for example, in the industry like ONGs and all, they are establishing one mobile van in which all the equipment is available, and whatever the samples they are collecting, immediately able to do it. But mobile kits and all only that is for field. We are using some of the mobile kits for water sample analysis and all. It is not like that. All the equipment, sophisticated equipment, also installed in the van, especially for the big companies.
Okay. How about this Petrel software, sir? Petrel.
Spectral softwares. I'm not thorough about those softwares, but there are so many remote sensing people can able to give you in detail. But there are so many softwares. Now we have a one project of the ONGC that is actually we have a stamps and all. There is some software which is we are using for that one only to understand the land subsidence and all. But similarly, there are so many softwares which are available for resource estimation and other things, right?
Okay, that we can download and we can do that.
Yes. Actually, some softwares we can freely download for 1 month. That is a trial basis and all. If you want you want to access the softwares, you have to purchase it. Sometimes the other oil companies will allow you to use those softwares. Okay.
Okay, thank you, sir. Thank you so much, sir, for your detailed lecture. 1 second.
Thank you. I will share the presentation to you. Okay, thank you.
Sir,
Thank you.
good morning, sir.
Yes.
Good morning, sir.
Yes.
Hello.
Sir, good morning.
Sir, good morning, sir.
Good morning.
Sir, I am Keshav Kiran.
Yes.
Sir, I have general doubt. Actually, in Pulivendala, it means Vemula and Vempale, near to Vemula and Vempale, so many white varieties deposits is present, sir.
Yes.
So, by using geomagnetic field method, shall we identify that one, sir?
Yes, yes. Actually, that those veins are very small veins,
Sir,
meter or 2 meters like that. Yes, even though those
sir,
are we can able to delineate in the horizon. In the Vemuland,
sir, sir,
there are two veins we are recently we are visited. Okay,
sir.
those veins also we can explore. We can able to detect. But thing is, the geophysical surveys is a costly affair. Okay,
Sir,
if you do with geological surveys, that is better.
sir,
Okay,
yes, sir.
because
Actually, so
the
many,
veins are.
so many geophysical present there. Some people are using for groundwater exploration.
Yes,
Some instruments was using that one, sir.
yes, yes, yes.
Uh, this type of instruments also used for that one, sir.
Yes, yes, you can use because the variety is itself is 4.5. Okay, the associated
Yeah,
rocks
yes, sir.
specific gravity is very less. Therefore, wherever
Yes, sir.
there is a contrast in the density, you can immediately
Sir,
go for the gravimeters. Okay,
sir.
right. Yes,
Okay,
we can use
thank
it.
you, sir. Yes.
Okay. Yes, if there are no questions, yes, I can be. Okay. Okay, madam. Thank you, everybody, for patient hearing. Thank you.
I think the best way to go. Good morning, sir. Sir, what is the sources of gases detected over ore deposits, sir?
Hello? Sir, are you there, sir? Sir,
Kneeling. Okay.
On the occasion of Holiday Nation webinar, today's talk given by Professor Satyan Reddy is one of the highly helpful to use one of the NAQ presentation mainly on recent trends exploration, mostly on geological, physical, geochemical, and geobotanical explorations. Also, how geological map can do by using the latest application, latest tool like remote sensing and this, and also explain 3D geological model, and also hyperspectral, and also how to estimate the hydrocarbon by using a different method. Thank you, sir. Thank you. I hope all students are benefited more and more. Also, related scholars also benefited. Thank you, sir. Once again, thank you.
Thank you, Raju sir, for your vote of thanks for the Satyan Reddy sir staff. So with this, the technical session is over, and tomorrow there will be two technical sessions, session 4 and probably the one is by Dr. Raghu, a scientist APSAC, Vijayawada, and the other technical session will be by Dr. D. Srinivas Sharma garu. So he's a chief scientist, CSIR NGRA. So hope probably tomorrow also the same link you can follow. Thank you by around 10:15 a.m. So thank you so much for all your participants, and yeah, the YouTube link of the two technical sessions were shared in the chat box, it seems. Hope you can use that and benefit it. Thank you so much for your participation. Hope to see you same tomorrow in the same link. Thank you so much.